All right. Good evening. So we are starting our physics class now. Could remember that last class we talked about motions and we were trying to check the graphs of motions. So today we want to concentrate on equation of motions. All right, equation that leads to graph. We have discussed displacement, we've discussed distance, we've discussed velocity, we've discussed speed, we discussed acceleration and deceleration as the case may be. So we want to check around all this. In terms of the graphical representation, we have discussed it too. So let's focus on the equation. All right. The equations of motions are majorly regularly three. All right. The first equation of motion, you use V is equal to U plus AT. This is the first major one. Probably I can just quickly take it from the fact that you can have average velocity times time or average speed times time. It depends on what you are saying. You can have A is equal to V minus U over 2 or V plus U over 2, then T. Something like, okay, distance, sorry, not acceleration, distance. Distance moved is average velocity times time. Distance moved. So from calculating distance as velocity times time, we have already established that velocity is the rate of change of distance with time. All right. So I can write V plus U, or V is equal to S over T. But when you want to know the total distance covered, the reason is because most times when you are covering a distance, your velocity is not regular. You don't have a uniform velocity. That's why we are using average of all the velocities. So we believe you are having a final velocity. We believe that you are having an initial velocity with which you started. And then when you find the average, of course, when you find the average of that and you multiply it by time, you are going to have the distance covered. So that's equation one. Okay, they call this equation one, but for me, I don't see it as a major issue. The ones we are going to concentrate on majorly is this one. This one is called equation 2. All these equations can be generalized into some other equation. We can generalize it into vertical equation of motion. We can generalize it into projectile equation of motion too. Yeah, definitely. Because projectile equation can be derived from all these equations of motion. Is anybody listening? Hello? Just to be sure that I am audible. Okay. So let me just continue. Then we now have another one. Okay. I think someone need to be muted. All right, fine. So let's move on. So we now have this. Then we now have another one that says that S is equal to UT plus half AT squared. All right, I'm going to give you the definition of all of this. Of course, we have established some of them last week. So all these things are just, they are not new to us. And then the fourth one, which is V squared, is equal to U squared plus 2AS. So when you have all of this, these are called equation of motion. All of these are called equation of motion. So any question you are given on motion, at least that has to do with linear motion, motion on a straight line. Maybe we should just begin because there is one for circular motion. So we should not module it together. These equations are basically for linear motion. Motion on a straight line. This is for vertical motion. We're going to give definition of those ones separately. And when it is for circular motion, we have that one separately too. But before we understand the concept of circular motion, we'll talk about that of vertical motion. So we can use all of this one to demonstrate this one number 1, I call this number 2, I call this number 3, I call this number 4. This order is necessary because definitely JAMB will not be asking us to derive equations, but I am not a proponent of cramming. I'm not a proponent of cramming. So I can use equation 2, equation 3, and equation 4 that I have here to derive the equation of projectile. The projectile motion, all right? The first one can be used to derive the time of flight. The second one can be used to derive the highest point reached, that is height. And then, of course, the third one can be used to derive for range, of course, of the range and then the height of the projectile motion. All right. So the next thing we're going to be talking about is when you have all of this, is there a way you can try to use vertical motion? You can generalize it into vertical motion. Generalizing it into vertical motion means that you are going to change some constants here. So here now, what we need to do is that S, when you have S to mean the distance, please note, S means distance according to this. U means initial velocity. Initial velocity or initial speed. Initial, VEL for short, velocity. Or maybe I should just write it out, velocity or speed. I'm using V and U interchangeably to mean velocity or speed. Then V means final velocity or speed. Final velocity or speed. I don't need to put slash again once I put all. Let me use slash. Can it slash speed? Don't worry. And then, of course, T retain its usual value as time in seconds. Time. What else again? A is there as acceleration. Acceleration. Okay. I think we have defined everything we need to define there. Yeah, there's nothing again. So we have all of this. Anytime we are given any equation on a straight line motion, these are the values we are going to use to get our parameters right. Now, the next thing I want to tell you is all of this can be converted, especially from equation 2 anyway, can be converted into vertical motion. When you have motion that is coming vertically, your acceleration on a linear space becomes acceleration due to gravity. That is G. One thing about vertical motion is that the nature of your movement will change, and then it will change the equation. The distance moved is not going to be horizontal distance, it's going to be vertical distance. So some parameters will change. What are those parameters that will change? S, which is horizontal distance moved, will turn to height of the flight. When you throw up a stone, the stone must have reached a particular height before coming down. So when you are throwing up a stone, your initial velocity will be given value. But when the stone reaches its highest point, final velocity is 0. All these things are what JAMB is testing. They are not even testing majorly calculation, most of the physics questions that you will have solved. They are based on understanding of concepts and application of concepts. All right. But you need to understand these equations to be able to flow well. So let me give you some things you need to know. All right. So for vertical motion now, vertical, I'm still under equation of motion. No? But now we are talking about vertical motion, because that one is directly a consequence of horizontal motion. So there are some things that will change. If you use V is equal to U plus AT, now what you need to know is that at the highest point, final velocity becomes zero. And I will explain that to you. When you throw up a stone, when the stone reaches its highest point, that stone will momentarily become stable, like it will stop. And when it stops, that means velocity, because it's not moving, the rate of change of distance with time is zero. So velocity is zero at the highest point. That's why this will be zero. Your U will be given value, but something will change. This addition will turn to negative. Why? Because your acceleration due to gravity is going against free fall. When you are throwing up a stone, you should know that the stone is going against gravity. So your G will become negative. So what I'm going to have at the end of the day will now become U is equal to GT. That's what you are going to have. That is, you are transferring this to the other side. So your U, initial velocity, will be product of acceleration due to gravity and time. All right, starting from the second equation of motion. Then when you have S is equal to UT plus half AT squared. Then, like I told you, this S is for horizontal motion, so it will change to height. Then you have UT, your AT square, your A will now turn to G, and because it's going up, it will go against gravity. It will be minus half GT square. That's what you are going to have. So the calculation of the highest point reach is product of initial velocity and time minus half acceleration due to gravity times square of time that is used. So I'm going to also box this as equation of vertical motion. I'm going to box this. And then, of course, the last one that we have, which is V square is equal to U square plus 2AS. Your horizontal distance, which is S, will turn to H. So V square becomes zero because I said at the highest point, velocity is zero. So you're going to have zero is equal to U square. Now, your acceleration due to gravity is still negative, so it's going to be minus 2GH. And then, of course, you can now rewrite this because this zero, you can transfer this, so it will be U squared is equal to 2GH. So we can put this also in a box. We can put this in a box, all right? Let's just squeeze it down there like that. So U squared is equal to 2GH. But this is when you are throwing it up. This is when you are throwing it up. When you are going up. So I'm going to use this one as moving up. So this is when it is going against gravity. What if you are dropping it from a height? If you are dropping it from a height, some things will also change. I'm still going to write all of this equation. When you are going up, this is what you have. Now, when you are dropping it from a height and it is coming down, what should happen? Let us check that. Dropping it from a height, so I'm going to be using this. That is, I'm dropping a stone from a height. So if I use V is equal to U plus AT, what will change? When I'm dropping a stone from a height, I'm holding it. So as I'm releasing it, initial velocity is zero when I release a stone because it will be momentarily stable, and then the velocity will now continue to increase. When it was about to hit the ground, that is when it will have the highest velocity. So When I'm dropping a stone from a height, initial velocity is 0, so I'll have V is equal to GT. Why G? Because it is coming alongside with gravity, so it is not going against gravity. Since it is not going against gravity, then this law holds. It is coming alongside gravity. That is one. Then second one, if I have S is equal to UT plus half GT square, what you are going to have here now, your S, which is distance, will turn to height. Your height will now become, since I said you are dropping it from a height, your initial velocity is 0. Maybe I need to write that somewhere here with another color, that U is equal to 0. All right, for the previous one, I can quickly squeeze it somewhere that V is equal to 0. V will be equal to 0 when the stone reaches maximum height. So let me keep this one here. When you are throwing it up, your final velocity is 0. But when you are dropping it, your initial velocity is 0. So we have already boxed this one here. So we can just make use of that. So that will now make the whole of this to become to 0. And once the whole of this is equal to 0, what I'm going to have is the highest point will now be 1 over 2 GT square. That's what you are going to have there. If you want to calculate the height from which you are dropping such a stone, it will give you this formula. So I can box it. Well, I want to box it. Okay, so I have this. Okay, this is nice. Yes, you have it. Okay, so the next one is that V square is equal to U square plus 2AS. Now, we have already established that our U will be equal to 0 because we are dropping it from a height. So it's going to be V square is equal to 0 plus 2GH. Your S is now an height. Your acceleration is now acceleration due to gravity. So you should quickly understand the substitution I'm using in all the equation. So at the end of the day, what you are going to have is V square is equal to 2GH. So I'm going to box this. So the equation you are going to use when you are throwing up a stone is quite different from the equation you are going to use when you are dropping a stone from a particular height. So I've given 3 things today. I've given the equation of the horizontal motion. I've given the equation of the vertical motion when you are throwing up a stone, and when you are dropping a stone from a particular height. So we have all of that. I don't know if we can quickly check on 1 or 2 questions. Let me see if I can lay my hands on jam question or physics from my, I'm not sure I have the book here. Let me quickly check. Just give me a minute. Let me check my, okay. Maybe we should just continue. Don't worry. If I don't see, we can quickly plug into other things. Let me quickly discuss circular motion so that we'll just combine all of those things together. Probably next class, we can look into questions. Yeah, so I will not delay the class on. So let's talk about circular motion. Circular motion. Okay. Of course, it is called motion in a circle. So you have this, and you have this. When you move from point A to point B on a circle, there is an angular distance covered. Okay, there's an angular distance covered. It is called omega, or you can call it any distance you like, but the circle will have a radius. When a particular object is moving in a circular motion, we have what we call V is equal to omega R. Omega R is, you can use this method Mathematically, I can use equation of arc of a circle to calculate the distance covered. But we are not actually calculating distance. We are calculating speed. So the angular distance covered times the radius of the circle will give us the speed. So if you want to find the angular distance covered, you can do omega is equal to V over R. All right. Then, of course, you can have acceleration, and that one is omega square R. Omega square R. To find this, this is how you can find the relationship between linear. Don't forget, I'm talking about circular motion, but there's a way you can convert it to linear motion. So the relationship between the linear velocity and angular velocity is what I'm showing you here. And the relationship between linear acceleration and angular acceleration. Linear acceleration can be converted into this. Linear velocity is this. So let me just box the two so you understand where we are going. And you can be asked to find for angular, distance covered and all of that story. You can use this method to calculate it. I would have loved that we have questions that we can just make use of, but I think I have misplaced the book. I have to take my time to look up for it, but it should be somewhere. Okay. Let me see if this will not be too, it shouldn't be too advanced. So I have the material here. Can I quickly, yes, beautiful. I have something here. So let me use this to work out. I know I should have enough question to work with. Okay. Let me see. I don't want to teach you something too advanced in a way. Okay, this one addresses more of the vectorial vectors. I'm going to take up this is projectile motion. Just hold on. Let me see if I can still see question. Okay, I think I love this. Please just note this question. It says, a car experiences a displacement of 40 kilometers in 20 minutes. A car experiences a displacement of 40 kilometers in 20 minutes. What is the average velocity in meter per seconds? This is just conversion. And I think I should quickly use this. It is in the process of solving several questions that we will now begin to see what is happening. All right. Note that to convert from meter per seconds to kilometer per hour, very simple. Very simple. Meter per second to kilometer per hour. Kilometer is 1,000 meters. All over 1 hour is 60 times 60. Okay, so if you do this, you cancel this, you cancel this, you cancel this. So what you are going to have is from meter per second to kilometer per hour. That is 10 over 36. 10 over 36. Let me do this. Just a minute. I'll do this. Let me go to the fresh page. Okay. Assuming I want to convert 36 kilometers per hour. 36 kilometers per hour. I want to convert it to meter per seconds. So 36 kilometers will be 36 times 1 kilometer is 1,000 meters. All over 60 times 60. So you cancel this, you cancel this, you cancel this, you cancel this. So you now have 36 times 10 all over 36. So this cancel this. So your answer is 10 meters per seconds. 10 meters per seconds. Please note. So we can use this to say 36 kilometers per hour is equal to 10 meters per second. All right, we can use this. Now, the question says that a car experiences a displacement of 40 kilometers in 20 minutes. So what would that be? That would be, for the question now, 40 kilometers in 20 minutes. 20 minutes will now be equal to 40 times 1,000 meters all over 20 times 60. 1 minute is 60 seconds. So 60 seconds times 20, that's what you have, 20 minutes. So this one can cancel this one. 20 here, 1, 20 here is 2. So I have 2 times 100 over 6. That is 200 over 6. 200 over 6. We can do the fractional this thing. If you want it in fraction, let's just try and put it in fraction. Let me see, because I don't always like working with calculator though. So I have 200, I have 6. 6 in 20 will give me 3. That's 18. I can bring 2 down. 6 in 20 again will give me 3. That's 18. I can bring 2 down. 6 in 2 cannot go again, so I'll put a point here. I can add 0 to my 20 now. 6 in 20 is 3, so we can see that it will always be 33.33. So it means 40 kilometers in 20 minutes simply means I will have 33.3 meters per second. 33.3 meters per second. 33.33 meters per second. Yeah, that's how to get it done. Okay, that's the question there. Okay. Let me see another question. Okay, this is another one. The question says, I'm just reading the question, so you need to listen very well. If you want to write it down, you want me to come again, I can do that. So pay attention to this. What is the average velocity of a man? What is the average velocity of a man who ran a distance of 3 kilometers? He ran a distance of 3 kilometers at the velocity of 7.5 meters per second. He ran a distance of 3 kilometers at a velocity of 7.5 meters per second, and he walked 1 kilometer at a velocity of 0.8 meters per second. I think we need to make use of calculator here, because we are going to be multiplying by 0.8 and all of that. Let me just read the question for you again. Maybe you can try on your own. If you can't, next class we can address it. Maybe I will just put this book somewhere and note this question particularly. But when you do your work right, you get an answer. I'm going to tell you the answer you work towards so that it will be easy for you to get an answer. I should be having about 5 to 7 minutes left for this call. So let me just quickly move on. What is the average velocity of a man who ran a distance of 3 kilometers at a velocity of 7.5 meters per second and walked 1 kilometer 0.8 meters per second? Full stop. That's the question. So the answer you should be getting is 2.42 meters per second. You should be getting 2.42 meters per second. Yes, 2.42 meters per second. Okay. All right. You should also know that average velocity can be calculated in terms of distance, total distance covered over total time taken. I think that will help you in solving this question. When you know the distance covered, 3 kilometers, that's 3,000 meters. Then the time taken, you don't know, but you know the velocity. So you can use the velocity, 7.5 meters per second, will make you calculate. I'm already telling you how to solve it. 7.5 meter per second is the velocity. V is equal to S over T, that is distance over time. The distance is 3,000 meters, which is 3 kilometers. So you can use that to find the time it takes in seconds. And then the next one, you walked 1 kilometer at a velocity of 0.8 meter per second. 1 kilometer is 1,000 meters. Then velocity is 0.8. You look for the time. So now total distance covered would be 4,000 meters. Total time taken is what you will calculate separately. Then you can use that to divide. So you should be able to get 2.42 meters per second. I think I've been able to help you if you just use that simple substitution. V is equal to, V is equal to S over T. Velocity is distance over time. That's what those are the simple questions you can use there. Okay. Let me see if I have any other question that can be attempted here. I've not started. Okay. This is another question that is nice. Let me dictate this last question. Let's see whether someone will be able to solve it. A boat heads 20 degrees west of north across a canal at a speed of 12 meters per second. This one is talking about resultant. And I think I should just keep this question when I'm talking about vectors. All right. When you have something like this, 20 degrees north of west. So this is west. West is here. This is north. So 20 degrees north of west. I want to be sure. Yeah, 20 degrees west of north. Okay, so you are starting from the north, you are going towards the west. So your 20 degrees should be here. If it were to be 20 degrees north of west, it means you are going to start from the west going towards the north. So your 20 degrees will be here. So you need to understand the grammar of those questions. It is 20 degrees west of north. So it means you are starting from the north going towards west and you have only moved 20 degrees. Okay, so he now said the speed across a canal at a speed of 12 meters per second. What is the resultant velocity of the boat? If the water of the canal flows due east at 12 meters per second, the same speed. So in this case now, I was using eraser, sorry. Let me see if I can still manage to, okay, it works. So the boat is going like this, the water is flowing like this. The question is, how will you be able to solve this? This is under, so you can just do something like this, and then you can do something like this, something like this. Yes, because it's flowing towards it. So at the end of the day, you are going to have your resultant like this. You're going to have your resultant here, R. This one is under vectors. I think I should just hold on to when I treat vectors, then I'll be able to attempt this. Okay. But for the previous question, I've given you what you need. You just used velocity is equal to distance over time. V is equal to S over T. Your first speed has been given. Your first speed was given as, let me quickly go back to it and pick it up for you. Okay. I want to see where I saw the question again. I think I have just 1 more minute left. I don't know. Okay. Aha. The man ran 3 kilometers at a distance of at a speed of 7.5. So you have 7.5 is equal to 3,000 over T. So you can get, let me call this one T1. You can get T1 from here when you cross multiply and then divide both sides. Then the next one, he walked 1 kilometer at a velocity of 0.8. So 0.8 is equal to 1,000 meters over T2. So once you have been able to get this done, So what you are going to do next is your average velocity V will now be S1 plus S2 all over T1 plus T2. So I will leave you to finish this one. Of course, your S1 plus S2 is 4,000 kilometers, for 4,000 meters rather, over T1 plus T2. So I leave you to conclude on T1 plus T2, and then you'll be able to get a correct answer. For me, so that's your average velocity, T1 plus T2. So you are the one that will determine T1 and T2, and then use it to divide 4,000. You should be able to get a correct answer from there. So I think I want to stop here. Next class, I'm going to bring up more questions concerning vertical velocity, circular velocity and motion, and then every other linear velocity. Okay, so thank you very much for the class.